So we will use this information to solve the next two questions. At time t equals 0, an object was launched from ground level directly upward. While the object was above the ground, its height in meters of 30 seconds was given by the equation h is equal to minus 4.9 t squared plus 34.3 t. So from this equation, we can say that the height of the object is a function of the time. So if we try to understand the context of this problem, let's say we have an object on the ground. Let's say we have a ball or any other object, and if we launch the object up, or if we throw the object upward, then the object will goes upward and then it will reach the maximum height. And after the object reaches the maximum height, then the object will goes downward until it reaches the ground again. So if we make this context or this situation into the graph of the height of the object, then our horizontal axis will be the time and the vertical axis will be the height of the object. And from our illustration before, we know that as time goes by, the height of the object will be increased until it reaches maximum point. So since the object was start at t equals 0, and when it was on the ground, then the height is assumed to be 0. So we start from the origin of the coordinate. So at the early time, then the height of the object will be increased until it reaches the maximum height, and then it will decrease until it reaches the ground again. So the graph of the function will be looks like this parabola. So we reach this sketch by considering the context of the problem, but we can also get this sketch by remembering that the given function or the height of the object is expressed as a quadratic function, and we know that the graph of quadratic function is a parabola. So we can actually confirm this form by two ways. The first one by considering the physical meaning of the problems, and the second one is by the mathematical meaning. And this vertex is actually correspond to this point. So this point is so the maximum height of the object, and if we have any other height below the maximum height of the object, then for every height, then we will have two times, or the object will reach the same height at two times. The first one when it goes upward, and the second one when the object goes downward. So this point is so when the object goes upward, and the second point so the height of the object when it goes downward. And we will use this sketch to solve the next two questions. The first question, how many seconds after it was launched did the object hit the ground? So we want to know the duration after the object was launched until the object hit the ground again. And when the object at the ground, it means that the height of the object is 0. And from this graph, we know that we have 2 points when the height of the object is 0. The first one is before it was launched, of course, when t equals 0. And the second one is this second value of t that we don't know. And the duration or the answer for the first question will be the difference between these two values. And to find the second value of t, since the object is at the ground, then we can set the height to be 0. And since we know that the height of the object is minus 4.9 t squared plus 34.3 t, then we can substitute this value into our left side. So we got this quadratic equation. And to solve this quadratic equation, we can use factorization method. And we can see that on both terms we have variable t. It means that we can factor out the t. And we have coefficient 4.9 and 34.3. And by using our calculator, actually we can check that 34.3 is divisible by 4.9, it means that we can factor out the negative 4.9, and negative 4.9 t squared divided by negative 4.9 t, then we get t. And if we check using our calculator, 34.3 divided by minus 4.9 is minus 7. And the result of this, the product of these two expression is of course 0. And since the product is 0, it means that t is equals to 0 or t minus 7 is 0. And from the second equation, we get t is 7. So the first value of t when t equals 0 is the first point before it was launched, and it means that t equals 7 is the second point. So the second point is 7. So the duration when the object hit the ground after it was launched is 7 seconds. So the answer is C. Next, we can move to the second question. For how long to the nearest second was the object at or above a height of 49 meters? So we want to know what is the duration when the object at a height of 49 meters or above 49 meters. Let's say we set a point of a height of 49 meters here, and if we make a horizontal line to the graph, then the horizontal line will intersect at 2 points. The first point is when the object goes upwards, and the second point when the object goes downward. And between these 2 points, then the height of the object will be above 49 meters. So if we want to know the duration when the object at the height of 49 meters or above 49 meters, then we can find when the height of the object at 49 meters. So let's say this is the first point and this is the second point. So we just need to find the t value of the height when the object reach a height of 49 meters. So we can set the height to be 49 meters, and we substitute the value of h to our left side. So we get this equation, and to solve this quadratic equation, we need to make the right side become 0. So we subtract both sides with 49. So if we subtracting both sides with 49, we get this equation. And from our first equation, we know that 34.3 is divisible by 4.9. So we can simplify our quadratic equation by dividing both sides with minus 4.9. And here we divided by negative value to make coefficient of t squares to be positive. So if we divided both sides by negative 4.9, then we get this equation. And to solve this quadratic equation, we need to find two values, which is the sum is minus 7 and the product is 10. And since the sum is a negative value, it means that the sum is negative value then and the product is positive value. It means that the two values are negative numbers, and we can find the two numbers that satisfy these two equations are negative 2 and negative 5, since negative 2 plus negative 5 is negative 7 and negative 2 times negative 5 is 10. So we will use these two numbers to break up the minus 2, 7, and we got t squared minus 2t minus 5t plus 10 equals 0. And now we need to factorize the first two terms and the last two terms. The first two terms has a common factor t, so we can factor out t and we get t times t minus 2, and the common factor of the last two terms is minus 5. So if we factor out minus 5, then we get minus 5 times t minus 2, and this is equals to 0. And now we have two terms, and these two terms has common factors t minus 2. So if we factor out the t minus 2, then we get t minus 2 times t minus 5, which is equals to 0. And since the product of these two expressions is 0, it means that the first terms or t minus 2 is 0 or t minus 5 is 0. From the first equation, we get t equals 2 and from the second one we get t equals 5. So it means that the first time when the object reaches a height of 49 meters when t equals 2, and the second time when it reaches a height of 49 meters when t equals 5. It means the duration, or for how long the object reach a height of 49 meters or above 49 meters, will be the difference between 2 and 5, which is 3. So the answer for this problem is C.